Hello, let us find the value of y in 3y plus 3 to the power of 2y equal to 3 to the power of 3y. Now, if you see this equation very well, you'll come to see that 3y exists in all the data. Now, how do we find the value of y? Stay tuned as we do that. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Now let's get started. To solve this, we are going to take all parameters to the right hand side, and that way we'll have 3 to the power of 3y minus 3 to the power of 2y minus 3 to the power of y, and this will be equal to 0. So in the next step, we are going to consider breaking up those integers, those exponents into smaller parts, and this will give us 3 to the power of, this is going to be 2y plus y, right? Minus 3 to the power of y plus y minus 3 to the power of y, and this will be equal to 0. Now let's simplify this. If you simplify this, recognizing the law of indices, remember in the law of indices, if I have a to the power of x plus y, this simply will give me a to the power of x multiplied by a to the power of y, right? Great. So that simply tells me that this can be 3 to the power of 2y multiplied by 3 to the power of y minus 3 to the power of y multiplied by 3 to the power of y minus 3 to the power of y, and this will be equal to 0. Good. Now let's look at how we can bring out one common term. And remember, I told you 3 to the power of y is common in all those data is given to us. So if I divide all these by 3 to the power of y, I'll be left with 3 to the power of 2y minus, this will remain 3 to the power of y minus, this will remain 1, and all these will be equal to 0. Now we've gotten to a point where we have to separate these two expressions. This is more of a zero product rule. So we're going to have 3 to the power of y as the first case, 3 to the power of y to be equal to 0. And as the second case, we are going to have 3 to the power of 2y minus 3 to the power of y minus 1 to be equal to 0. So let's solve this part first. For every value of y equal to 0, 1, 2, 3, you find out that y can never be equal to 0. But from this expression, we are told that y, 3 to the power of y is equal to 0. So for every value of y, 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, it can never be what? Equal to 0. So that means we are going to neglect this solution because it cannot be possible. Now we're going to work with this other solution. If we work with this other solution, you come to see that we can simplify this and then get a valuable answer. From that law of indices, I can say this to the power of y multiplied by the power of 2 minus 3 to the power of y minus 1 equal to 0. So this will look like more of an exponential equation. From that exponential equation, I can take my 3 to the power of y to be equal to x. So if I consider my 3 to the power of y to be equal to x, so that expression will now give me x squared minus x minus 1, and that will be equal to 0, which is a quadratic expression. So from here, I can see that from quadratic equation, my 1a will be 1, my b will be equal to -1, and my c will be equal to -1. So how do I simplify this to find the value of x? The value of x this time around will be equal to, using the quadratic formula, minus b plus or minus the square root of b squared minus 4ac divided by 2b, and this is the quadratic 2a, which is a quadratic formula. So if we want to simplify this, we are going to get the value of x. So from here, the value of our x will be equal to negative multiplied by -1, right, plus or minus the square root of -1 square, which is b, minus 4 multiplied by 1 multiplied by -1, and all these will be divided by 2 multiplied by 1. So the value of our x will be equal to 1 plus or minus the square root of 1 minus, this will become plus 4 divided by 2. Because minus times minus is equal to plus, 4 times 1 times 1 is equal to 4. So the value of our x will be equal to 1 plus or minus the square root of 5, and this will be divided by 2. So the value of our x is equal to that. So the value of our x can now be equal to 1 plus root 5 divided by 2, or it can still be equal to 1 minus root 5 divided by 2. So from that expression, you have to recall that we said 3 to the power of y is equal to x. And recall that our main aim is to find the value of y. So 3 to the power of y, we said, is equal to x. So if x is this, then 3 to the power of y will be equal to 1 plus root 5 divided by 2, or we'll have this to become 3 to the power of y equal to 1 minus root 5 divided by 2. So if we simplify this, what are we going to arrive at? To simplify this, you come to see that this is going to give us, for every value of y, this is going to remain positive, right? And for every value of this can never be positive, it is negative, because root 5 is up to 2 point something. So 1 minus this will give us negative. So negative can never be equal to positive. So as a result of that, we are going to neglect this expression. And then we'll come to this, and to this we are going to take the log of both sides in order to find the value of y. So this will give us the log of y base 3 equal to the log of 1 plus root 5 divided by 2. So what do we do here? We are going to simplify this. Our y log 3 will be equal to, this is going to simply give us the log of 1 plus root 5 minus the log of 2. Remember the laws of logarithm, the division law of logarithm. So if I divide here by the log of 3, I will equally divide all this by the log of 3. That way, I can be able to find the value of y. So from that expression, the value of y will be equal to the log of 1 plus root 5 minus the log of 2 divided by the log of 3. So we can simply simplify this expression to get a decimal value for the value of y. So this is the final solution to that expression that was given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to kindly subscribe to my channel, for it means a lot to me, in order to get updates of our videos once they are uploaded. Thanks so much for watching once more, and bye bye for now.